Hello viewers, you are welcome to this video. Today I want us to look at binomial theorem for any rational index. Binomial theorem for any rational index. Now, binomial theorem for any rational index states that if n is any rational value and x is greater than or equal to -1 but less than 1, then 1 plus x all raised to the power n is equal to 1 plus nx plus n minus 1 s squared over 2 factorial plus n minus 1 n minus 2 s cubed over 3 factorial plus and so on plus x raised to the power n. Yes, this is a binomial theorem for any rational index. That is, if n is any rational value and x is greater than or equal to -1 but less than 1, this one holds. Yes, this holds. You see, look at it, it follows a pattern. Follows a pattern. We get to this one. Yes, 1 plus nx, then n minus 1, s squared over 2 factorial. So if this is 2, then this one will be 2. Isn't it? And if you write this and that, then it goes with s squared. 1, 2, 3. Then you go with s cubed over 3 factorial and so on. And you'll get to x raised to the power n. Now, you can use this formula to do some expansions. For example, when you are given 1 plus x raised to the power, say 1 over 2, you can use this formula to expand this. You can also use this formula to expand something like 1 plus x raised to the power, say 4. Yes, you can do that. Okay. Now, when we are saying that this holds only when n is any rational value. Yes, when n is a rational number. And the rational number is a number that can be written in the form a over b, where a and b are integers and b is not equal to 0. Okay, so let's use this one to solve some questions. Yes, you can do something like this to expand. Question number 1. You can say write down the first 3 terms. The first 3 terms in the expansion. Of cube root of 1 plus x. Yes. We can be given something like this to solve. Now, solution. Let's look at the solution. Now, this is what you have been asked to expand. So, we have cube root of 1 plus x. Now, cube root of 1 plus x is the same as 1 plus x all raised to the power 1 over 3. You see it? Now, let's write the formula. You know that 1 plus x all raised to the power n is equal to 1 plus nx plus n minus 1 s squared all over 2 factorial plus n minus 1 n minus 2 s cubed over 3 factorial plus and so on to plus x raised to the power n. Do you see? Now, let's try to compare what we have been asked to expand with this formula. If you compare, so comparing this one, look at the board. We have been given this one. So comparing this with this one, you can see that 1 is equal to 1, x is equal to x, but n is equal to 1 over 3. So what this means is that you can just look at this formula, and whatever you see n, you write 1 over 3. So you can say comparing 1 plus x all raised to the power 1 over 3 with 1 plus x all raised to the power n is equal to 1 over 3. The rest are the same. Yes, n is equal to 1 over 3. So we are going to use this formula. So this means that 1 plus what we are given cube root of, so therefore cube root of 1 plus x. Let me write the root 1 plus x, which is equal to 1 plus x all raised to the power 1 over 3 is equal to, so you are looking at what is happening in the formula. The formula says write 1. So I've written 1 and then write n. And n, don't forget that n is 1 over 3. Are you seeing it? So 1 over 3 times x. The x is still x. Plus n. N is 1 over 3. Are you seeing it? And then when you come here, they are saying 1 over 3 minus 1 x squared all over 2 factorial. Don't forget the question we asked to write down the first 3 terms. So we can say plus and so on. You don't have to continue. Yes. We have been asked to write the first 3 terms. So let's try to expand it. So this is equal to 1 plus 1 over 3x. Now let's look at this one. Now this one is going to give us 1 over 3. Are you seeing it? Times. Now 1 over 3 minus 1 will be negative 2 over 3. Are you seeing it? And then you have s squared here. S squared here. All over 2 factorial is 2. Now let's look at what is happening. 1 over 3 times negative 2 over 3 will give us negative 2 over 9. And this is being divided by 2. So it's the same as being multiplied by 1 over 2. And these 2 will cancel these 2. So I'm going to get negative 1 over 9 s squared. So the whole of this will be negative 1 over 9 s squared. I see it. So this will be the answer to this. So it means that when we expand this, plus and so on, don't forget, because you have been asked to write the first 3 terms. The first 3 terms. So this will be the solution to this question. Yes. Now, viewers, let's look at another question and bring this lecture to an end. Yes. Because we'll be able to understand how we are going to solve the 2 questions. Then, when they are given similar questions, you should be able to solve them. Now, let's look at a question like this. 2. You can say, write down the first 3 terms. The first 3 terms. The first 3 terms in the expansion of 2x minus 1 all raised to the power 5. Yes. So let's assume that I have been asked to use the binomial theorem for any rational index to solve this one. Yes. Because when we are not restricted, this one you can decide to use the Pascal's triangle. You can decide to use it. Yes. But let's assume that I have been restricted to use the binomial theorem for any rational index to solve this. So let's look at it. So let me clean this side. We are done with this. Solution. Now, viewers, let's look at the question. We have 2x minus 1 all raised to the power 5. Now, viewers, let's look at the question. You see, the formula that we are supposed to use is 1 plus x all raised to the power n. Do you see it? And let's look at what is happening here. So it means that you should be able to work on this one so that it will look like this. It will be 1 plus something raised to the power 5. Yes, so you should be able to rewrite this question so that it will conform to this. Because at the end of the day, this is the formula you are going to use. 1 plus x raised to the power n is equal to 1 plus nx and so on. Yes. So this is the same as, look on the board, this is the same as negative of 1 minus 2x all raised to the power 5. Now, if we are expanding this, look on the board, You see that it's going to be like this. -1. You see, this one is -1. -1 here times -2x will be positive. All raised to the power 5. Isn't it? All raised to the power 5. So, even this one, I can decide to write it this way. Yeah, I can decide to write this way so that it will be. I can just say -1 has come out here this way, so that everybody will understand. And this is equal to, so if we're expanding this one, this is the same as -1 all raised to the power 5 times 1 minus 2x all raised to the power 5. Yes, so this is the same as this. Now, if you look at this one, you can see that it conforms to the binomial theorem. Yes, the formula you are going to use. Yes, so therefore, using this formula, if you use this formula, so 1 plus x. So we can just say that comparing, so you are going to work on this one, you are going to work on this. So comparing, let me write the formula first. The formula is 1 plus x all raised to the power n. And this is 1 plus nx plus n minus 1 s squared over 2 factorial plus n minus 1 n minus 2 s cubed over 3 factorial plus and so on to plus s raised to the power n. Okay, so you have it this way. Now comparing this one, 1 minus 2x all raised to the power 5 with, let me write this one with, all raised to the power 5 with 1 plus x all raised to the power n. If you compare, you can see that 1 is equal to 1. But x, this x is equal to -2x. Are you seeing it? And so comparing this one with this, you can see that x is equal to this, and n is equal to what? 5. Yes. So this implies that 1 minus 2x all raised to the power 5 is equal to, we are going to use the formula. And the formula says you should write 1. So you write 1. And then n. Don't forget our n is what? 5. So 5 times x. And this x is now -2x. That's why you have to compare. So this is -2x plus n. Our n is 5. N minus 1. So n minus 1 will be 4. X squared. But don't forget that x is what? -2x. So it's going to be -2x all squared over 2 factorial. And you were asked to write down the first 3 terms. So we can end here, plus and so on. This is equal to 1 minus, this time this will be -10x. Are you seeing it? Now let's work on this. -2x all squared will be 4x squared. Now 5 times 4 is 20. Times this 4 will be 80. Divided by 2 factorial, which is 2, that will be 40. Are you seeing it? So this one will be plus 40x squared. Are you seeing it? Because this one will be 4, this 20 times 4. And that is 80 divided by 2, 40. So plus and so on. Viewers, we can't stop here because we are not asked to expand this. We are given this one. So therefore, you go back to the question. 2x minus 1 all raised to the power 5. This was what you were given to solve. And we wrote it as this. It's equal to -1 raised to the power 5 times 1 minus 2x all raised to the power 5. And this is equal to, now, -1 raised to the power 5 is -1. Are you seeing it? Times, now you have the answer for this one or to this one. To be 1 minus 10x plus 40x squared plus and so on. Are you seeing it? So finally, if you expand Negative 1 times 1 will make this one negative 1. Negative 1 times negative 10x will make this one plus 10x. And then this one will be negative 40x squared plus n. So this will be the solution to this one. So viewers, this is how the binomial theorem for any rational index works. It is not difficult at all. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr. Thank you very much.